Hi, this video lecture is about variables in C, integer and floating types, and cast conversion. After this lecture, we will understand the concepts of variable, data type qualifiers. We'll also understand the integer and float data types, literals, typecast, and const qualifier. A variable is a name given to a place in memory that the program can operate on. Each variable in C is associated with four properties. First, a specific type, which determines the size and layout of the variable's memory. Second, a unique identifier that is the name of the variable. Third, the range of values that can be stored within that memory. Fourth, a set of operations that can be applied to that variable. A variable is simply declared using the syntax type identifier. At the bottom of the slides, you can see valid declaration of variable I of type int, variable myCharacter of type char, variables f and salary of type float. In computer science jargon, C is a statically typed language. The types cannot be left ambiguous before variables are used. What this means in practice is that we must declare the type of every variable we use in C. Every variable must have a type, an identifier. The type of a variable determines how much space it occupies in memory and how the stored bit pattern is interpreted. In C, we have three primitives or fundamental data types: integer types, int, floating types, float, and character types, char. We have user-defined data types that are obtained by using more than one primitive data type: typedef, enum, struct, union. We have derived data type, array, pointer, function data type. We also have a special data type called void that is used as a placeholder where we would put a data type to represent no data. In addition, before the type, we can have a qualifier that is a keyword that is applied to a type, resulting in a qualified type. So before a type, you can use a qualifier. Examples of qualifiers are signed, unsigned, short, long, and const. Integers include 0 and positive or negative whole numbers. That means that no fractional part is allowed. The memory used to store integer types varies depending on the machine we use and on the qualifier, short or long. Integers are typically 32 bits long on modern CPUs, so you can represent 2 to the power of 32 values using an int. You can use qualifiers, unsigned, if you want your integer to represent only positive values. In some cases, you don't need 32 bits for representing your integer value, so you might want to use short. On the contrary, if you need more than 32 bits, you need to use the long qualifier. An integer literal defines a compiled time constant whose value is specified in the source file. There are some rules on how to use integer literal. So on the slides, you see some invalid values for integer literals that are crossed. An interesting point is that you can use a prefix to specify the base or the radix. For instance, you can use 0x for hexadecimal numbers or 0 for octal. You can also use a suffix after the number. For instance, you can use U or L for unsigned and long integer. Floating types variables can represent real values, numbers, including fractional values. The size of float types varies depending on its implementation. We have basically two primitive kinds of float types, float and double. Float refers to a single precision floating point type, and it is typically 32-bit long. Double refers to a double precision floating point type, and it is 64-bit long. You can also use the qualifier long for an extended precision float. A floating point literal defines a compile time constant whose value is specified in the source file. On this slide, there are two possible syntaxes for float literals, with and without decimal point. As for the integer literal, you can use a suffix, in this case, F for float and L for long. A typecast is a conversion from one type to another. There are two kinds of cast, implicit and explicit. Implicit cast is done automatically by the compiler, while explicit cast is done by yourself. A very important point is that during the cast, it's possible for implicit conversion to lose accuracy, sign, and having arithmetic overflow, underflow. The compiler will not protect you from these dangers. However, the compiler might give you a warning generated at compile time. In the example code of these slides, we have two variables, x of type int and y of type float. And we have an example of both implicit cast using a suffix from float to int and explicit cast from int to float. C allows you to declare constants using the const qualifier before the type. When you declare a constant, you do a variable declaration, but the value cannot be changed. Const is often useful when you do a parameter passing with a function, because you guarantee that that function will not alter the values of that variable. This was the last slide. Thank you.